when you're ready.
So first I'll be starting off with some introduction with background information. So the placebo effect has been debated and researched since the 18th century. The placebo effect is known as your mind tricking you into thinking that a fake treatment is giving you real results. The substances of a placebo can be in the form of a pill, injection, or any liquid. There are two main reasons why a person experiences the placebo effect. The first and most common is expectations. If a patient has higher expectations towards a treatment, they're more likely to see results from it. In addition to this, the main part of it is the doctor-patient interaction. If a doctor uses terms like high quality, expensive, or very effective, then they're more likely to see results because of the positive feedback. The second one is genetics. Dopamine is a chemical in your brain. Those who have higher levels of dopamine are known to be more prone to the placebo effect. In addition to this, those who have genes that are a high-level dopamine version also have higher pain perception. Looking into the neuroscience of the placebo effect, there are three main parts of the brain that are most affected during the placebo effect. The first is the thalamus. So the thalamus is involved with sensory and motor signals that help regulate your alertness and wakefulness. In a Dartmouth study, it was shown that the thalamus is correlated with your sensations of pain, and this part of the brain was greatly affected during their placebo treatments. The second is the posterior insula. The posterior insula is involved with the early symptoms of your pain and is also the only location that can stimulate your pain. During these Dartmouth experiments, it was seen that there is a reduction to the activity in this area, meaning that there is less pain being stimulated. Lastly is the prefrontal cortex. The prefrontal cortex triggers your opioid release, and this blocks your pain. And during these Dartmouth experiments on placebo treatments, it was seen that there is an increase in activity there, meaning that there's more pain being blocked. The first demonstration of the placebo effect was in 1799, and it was by the British physician John Haygarth. John Haygarth saw that there's Perkins tractors being sold, and these were very expensive metal rods that were marketed to draw disease away from the body. He believed that these were a scam, so what he did was he put it to test. He decided that he would take a wooden tractor or wooden rod that looked very similar to the Perkins tractor, and he told his test subjects that these were the Perkins tractors. His results showed that 4 out of 5 of the test subjects saw improvements to their physical symptoms. Now I'll be going through my question and goal of my experiment. So my question has two main parts, and first the general is just, can the placebo effect be reversed? And then more specifically to my experiment, I was wondering if someone is unaware of the substance that they're taking, will they still receive these expected results? And for my experiment, this is specific to energy drinks. So my gap in research is that all placebo experiments online are based on ineffective substances creating improvements to someone just because they believe that it's going to happen. And so I wanted to dive more into if something that is scientifically proven to give you results, like caffeine, will still give you those expected results even if you're unaware if you're having them. I knew I wanted to do a psychological topic because I think it's very interesting. Along with this, the brain is really hard to actually study and create conclusive results, so I found that there's a lot of gaps in research that I could dive into that didn't involve high-tech equipment. So what is the purpose of this experiment? So a lot of placebo treatments can greatly affect and help improve depression, fatigue, pain, Parkinson's, and even allergies. So what is also the further purpose is that it is really important to be able to take into consideration every possible outcome of any form of medication that you're giving to patients. You should be able to know what can make it more effective and what makes it less effective. Going along with this, I think this experiment can help determine the great effect that how a treatment is being displayed can have on how you interpret it. Along with this, many scientists do believe that placebo treatments end up having more results than clinically proven drugs. Many believe that there should be more placebo treatments and that this can help take away any other effects that may happen from clinically proven drugs. So my hypothesis for my experiment is that I do believe that the group that is unaware that they're having the energy drink will receive less symptoms from caffeine than the group that is aware that they're drinking the energy drink. So now I'll be taking you through my methodology. So I chose to use the Reign Rainbow Sugar energy drink that is sold at Amazon, Walmart, or even just the Reign website. So I chose this because it is a very popular energy drink. It's known for having a good taste, and it gives people consistent increases to their energy. Looking more specifically to the ingredients, the Reign Rainbow Sugar energy drink has 0 grams of sugar, which means that also just has 0 grams of included sugars. I didn't want any sugar to have an effect on people's symptoms because some people take sugar differently. In addition, each can has 300 milligrams of caffeine. Looking more specifically at the ingredients, the main one to look at is coenzyme Q10. So coenzyme Q10 is an antioxidant that's produced by your cells. So this can help naturally increase your energy and is a very common ingredient in most energy drinks. In addition to this, it can help with migraines, heart conditions, and just physical activity and being able to increase your energy. So to look at my qualitative research and the observations I made, I need to research what were the most common caffeine symptoms. And what I found was I needed to look for and ask the subject about having any jitters, anxiety, wakefulness, restlessness, or any talking speed increase that they felt. To make my data more conclusive, I knew that I needed a more quantitative data, and what I used was wrist heart rate monitors. So the wrist heart rate monitors I used connected to the VeryFit Pro app, and this allowed me to see the heart rate at every second of the person changing in any way of increase or decrease, or just constant. So heart rate monitors on your wrist look at those major arteries that are in your wrist and forearm, and these will be the radial and ulnar arteries. And these help provide blood to your skin. In addition, wrist heart rate monitors use LEDs, which are light-emitting diodes, and they also use sensors to be able to detect when your blood vessels are expanding to be able to track your heart rate. So my experiment, I chose to use 30 minutes total, as it is known that caffeine typically takes 15 to 20 minutes to see any form of symptoms, big or small. In addition, I gave each test subject half a can, which equaled 1 cup of the liquid, which also totaled to 150 milligrams of caffeine. So then for my data, I used 2 different tables, and these stayed consistent between the control group and the placebo group. On the top, you can see that I tracked the feelings before, the heart rate before, and then the feelings and heart rate after 10 minutes, and then after 30 minutes. And then at the bottom, I have a table that is just for my overall observations, as maybe it can be easier for me to see and notice any differences compared to the person themselves if they aren't focusing as much on it. So my main limitation was my number of test subjects. It is very difficult to have willing subjects when there's a possibility that they would be in the group that is unaware of a substance that they're consuming. The next was the amount of drink consumed. If I was transferring it to a measuring cup and then to a cup for them to consume, there is a possibility of some of the liquid being left behind, or they might have not consumed some of it, left at the bottom, which means there might have been a various amount of milligrams of caffeine being consumed. Lastly was the heart rate monitors. They could have had an equipment error that I might have been unaware of, but to try to limit as much error as possible, I made sure each test subject was using the same heart rate monitor to allow any form of error to be decreased. So for my conclusion and analysis, so for the subjects that did know that they were drinking it, many of them said that they felt more energized or they felt jitters. Some of them felt both of those, and then some of them only felt one or the other. But all of them did display some form of increase in energy or jitteriness and anxiety. For my observations for the subjects that did know, all of them displayed changes in sitting positions, all of them had an increase in their talking speed, all of them had jitters, maybe hand cracking, and when I concluded my experiment, every one of them had stood up right away, like ready to move around. So looking at the heart rates for the subjects that did know, all of them experienced some form of increase throughout the entire experiment. Subject 1 went from 66 to a high of 97. Subject 2 only went from 80 to 87, but still experienced an increase. Subject 3 went from 60 to 76. And then subject 4 went from 66 to 114 throughout the entire 30 minutes. When looking at the subjects that did not know, all of them at some point of it said that they felt either slightly the same as before or exactly the same as before. In addition to this, many of them said the words that they were just chilling, they didn't feel any different. One did say that they felt slightly more awake than before, and then another said that their stomach felt uneasy, but they did not feel any jitters when asked about that. For my overall observations, all of the test subjects that did have jitteriness before, it remained constant throughout the entire 30 minutes. None of it was increased. For those who did not have any jitters, I did not examine any extra jitters or any form of changing sitting positions or anything else. Subject 4 did say that they felt slightly chattier. When I examined, I felt that they were chatty before and had a slight increase, but compared to the group that did know and their increase in talking speed, I did not consider this subject an outlier to the experiment. So for the heart rate, all of them experienced either constant or a decrease in their heart rate. Number 2 went from 70 to 72, but back down to 71, remaining very constant, while all the other ones had some form of decrease throughout the experiment. So my conclusion was that my hypothesis was correct. The control group did experience more effects from the caffeine compared to the other group or the placebo group. So this, in a smaller sense, can be taken into consideration by saying that there is a possibility that symptoms can be taken away just by being unaware that they should be receiving those symptoms. In other words, the effectiveness can be reduced just by your mental perception. So another way of saying this is that my experiment can show that your mind may be able to trick science in general. For future experiments, I would recommend using more test subjects, and this would create less outliers. In my experiment, I cannot control whether someone had outside stressors that might have increased their heart rate for the control group. So having more test subjects would take away this outlier and be able to provide more data that makes it more consistent. In addition, I would choose to have the tests all done at the same time of day to be able to know if someone has eaten a lot before, because this may affect the caffeine, and then also some people who are done later afternoon might have already had some form of caffeine that might have affected their tolerance.
Okay, thank you. Some questions. How did the choices you made when designing or implementing your method impact your process?
I knew right away that I needed to both have qualitative and quantitative research. So I think for me, it was mainly looking at what I wanted to track that provided me more concrete data rather than just observations. I already knew that the main thing that I would look for with caffeine would be jitters and any restlessness, but I also wanted to make sure I found an effective way to track the heart rate. So this greatly affected that because I know for some people, they told me that Apple Watches were very inconsistent for them. So I really had to look into what equipment I was using to be able to track this consistently for each person.
Okay, thank you. How do your findings provide direction for future research?
I think it's really important in looking at how different treatments or different substances that may have side effects could be taken away if they're unaware of those side effects. So for example, different treatments, when you're given them, they tell you, oh, you could get this and this and this. You could maybe get weight gain or maybe weight reduction or any headaches and stuff. But maybe this could possibly show that if they're unaware of those possible side effects, they won't notice it as much, and they also might not receive those side effects just because of their psychological perception of it.
Okay, thank you. What was the most important research skill you developed as a result of this process?
I would say the idea of making sure you have all your background information done before proceeding to your lab experiment. I think it is really important for me to understand what is going on in the brain when the placebo effect is happening, rather than just what the placebo effect is as a whole, because this helped me understand both just what observations I should be making, and also how the placebo effect goes past just the expectations, but also it is actually scientifically defined within your brain and different parts of your brain.
Okay, thank you. All right.